Good morning, everyone. Today we are starting module 1 of Mechatronics. In this module, we will understand what mechatronics really means, why it is important in modern engineering, and how sensors and actuators make systems intelligent. The module forms the function for all future topics, so please listen carefully. What is mechatronics? First, let us understand the term mechatronics. Mechatronics is a Japanese word formed from two parts, mecha from mechatronics and tronics from electronics. In simple words, mechatronics is the integration of mechanical system with electronics, control system, and computers to create smart products. Why mechatronics is important? In today's world, machines are no longer purely mechanical. They must be accurate, fast, automated, and intelligent. Mechatronics helps engineers design such system by combining multiple engineering disciplines into one complete system. Elements of a mechatronic system. A typical mechatronic system consists of five main elements: mechanical system, sensors, actuators, control unit, and softwares. Sensors collect data, the controller process it, and actuators perform the required action. All these parts work together as one system. Advantage of mechatronics. The biggest advantage of mechatronics is better performance at a lower cost. These systems are flexible, reliable, and highly productive because sensors continuously monitor the system. Maintenance become easier and system life increase. Disadvantages of mechatronics. However, mechatronics also has some limitations. The limit cost is high. The engineers must understand multiple subjects. Also, covering all the machines into mechatronic system is not always easy. Mechatronics applications. Mechatronics is used everywhere around us. In automobile, we have ABS, airbags, and cruise control. In medical field, we have surgical robots. In manufacturing, robots and CNC machines are used. Even home appliances like a washing machine use mechatronics. What is sensors? Now let us move to one of the most important components in mechatronics, sensors. A sensor is a device that detect a physical quantity such as temperature or pressure and convert into an electrical signal. Sensors and transducers. A transducer converts one form of energy into another. A sensor is a type of transducer that produces an electrical output corresponding to the physical quantity being measured. Performance characteristics. To select a sensor, we must understand its performance characteristics. These are divided into static characteristics and dynamics characteristics. Static characteristics describe the sensor behavior under steady condition. Important parameters include range, accuracy, sensitivity, resolution, and error. Range and span. Range and range tell us the minimum and maximum values of sensors can measure. Span is simply the difference between these two values. Accuracy and sensitivity. Accuracy include how close the measured value to the true value. Sensitivity shows how much the output changes for a small change in input. Resolution and stability. Resolution is the smallest input change that can be detected. Stability refers the ability to sensors to give same output. Hysteresia and repeatability. Hysteresia is a difference of in output. When input increase and decrease, repeatability indicate how consistently a sensor perform for the same input. Classification of sensors. Sensors can be classified based on their operation principle, output type, power requirement, and applications.